Good evening, everyone. Welcome all to the Bzign Labs Bzign Talk. We are Bzign Labs situated in Kerala, and also we are Autodesk learning partners and member of Indian Green Building Council. And we do BIM trainings for students and corporates, and also BIM implementations support for corporates and organizations, and also we do BIM project outsourcing and BIM placement services. And you can contact us through these email IDs, WhatsApp, Facebook, web ID, and LinkedIn IDs. So I am Vijina, technical engineer of BIM Labs, and this is my mail ID. So today I am here to talk over a topic optimization of precast construction planning using BIM. So these are my this project's agendas. First is introduction to BIM, then workflow. It's precast. What is precast construction? Autodesk Revit, about Navisworks, then about Primavera, and then what is BIM 360. So, precast construction is one of the most promising solutions to the fast growing infrastructure in any country. So, the precast construction has more advantages over cast in place construction, including better quality production, speedy construction, less wastage, less manpower requirement, safe construction site, etc. So we all know that in precast construction, structural components are standardized based on the structural production requirements based on the which is produced in plants or yards at a location which will be nearer to the construction site, and then it is cured, transported to the sites, and it is erected. So planning is a crucial stage for the successful completion of any precast structure. And effective, detailed, and advanced planning is necessary for any precast construction project. Thus, the building information modeling benefits the user by providing a platform which enables and create and manage all the aspects of a building with the help of numerous virtual models. With BIM, buildings can be created like virtually before they are constructed at the site and have many features including like model-based cost estimation, better builds, better collaborations, and communications, etc. So this is CAD workflow. We all know about the what is CAD workflow. It's a traditional method, and in this method we create hand drawings like 2D drawings, etc. And it is computer-aided technology. And in CAD, we know that we prepare everything starting from like 2D, and it also ends in 2D, but not in 3D. 3D can also be prepared, but it is like it is optional, and but it is optional, but it's not relevant, right? So why do we need a better workflow? Because because by using the CAD for rework and updation, it will be very difficult, and we all know that. That means a small correction needs a number of corrections in all views, all corresponding views like elevation. If we are creating or making any correction in plan view, all the corresponding views like a section, elevation, all the view we will have to update all the views. So it is a very hectic process, and nothing is interconnected. So a small correction needs a number of corrections in so many corresponding views, and also coordinations and clashes cannot be detected. And in conventional method and in 2D methods, a long methods are needed for finding the clash and resolving that clashes, which is created in the models. So there is no method for time management in CAD workflow, and also no method for cost estimation, and only there is some kind of manual methods, and there is also no method for checking the energy efficiencies, then like solar efficiencies, shadow analysis also. And for overcoming these limitations, like we need a better workflow, right? So in CAD workflow, it didn't have any control of it. It didn't have control over budget, and didn't have any control over time, and no, there is no method for finding the sustainability of the building. So we need a better workflow. So that is BIM, that is building information modeling. know what is BIM? BIM is Building Information Modeling is a disruptive technology in which construction at this precise moment and the opportunity to take the advantage of the technology by combining it with like prefabrication should not be wasted. And the adoption of BIM represents a complete revolution in the construction environment since it changes the construction processes in every aspect. And the purpose of this project is to represent the prefabrication components clearly for relating them with the most conceptual and theoretical concepts used in the construction. And like this will definitely help the designer for the design of the building components. Then the BIM benefits are presented with the potential of using this technology. And clearly, the BIM is a 3D intelligent 3D model based on the process that gives our model based process which gives like architect, engineer, construction professionals and insight and tools to more efficiently plan, design, construct and manage buildings and infrastructures. Precisely, building information modeling is about everyone understanding a building through a digital model, and the digital model will hold all the informations that the construction professionals should need to design, construct, and maintain that building. So the informations that we are feeding inside a digital model, it grows with increasing the level of details so that it reflects the building as it is what it is built. Then it is ultimately used. So the application of BIM or BIM technology is a vast construction management, vast in construction management, then in facility management, and in also in the prefabrication. All these areas are getting benefited using the BIM. That brings us our topic, optimization of precast construction building, construction planning using BIM. So these are the benefits, like all these things, updation and rework, and for the coordinations and clashes, and also for the time management, like for the cost estimation and the energy efficiency, we need a change. So that's where we are thinking about building information modeling. So here you can see BIM in AECO life cycle, and this AECO means architectural engineer and construction operation. Here you can see the BIM cycle. First one is programming, and next is programming and conceptual design. For every project, the key person will be the owner, right? Of course, he will be having the ideas about the project, but firstly, the owner will convey ideas to the architect, or and also the requirements, right? Then the architect will create an initial design to please the client, and that particular concept we can call it as a conceptual design, right? So here you can see the programming stages also. Here you can see the programming stages also, and then we have the visual programming techniques that helps to make the complex and multiple design outputs to generate multiple design outputs. We can use the visual programming technique, and also we can use visual programming scripts and crafts, and we can reduce our working time and can create so many complex geometries using the program techniques. Also we can make conceptual designs also. Once the conceptual design is confirmed, we have to pass forward that like conceptual design to the detailed design part. So mainly there are 5 types of detailed modelings are there. One is architectural, then structural modeling, then mechanical modeling, then electrical, and then plumbing models. So all these models have to be created by corresponding engineers like architect, structural, mechanical, etc. Once the architectural drawing is completed, then it have to be passed to the structural engineers so they can plan place structural elements like columns, beams, all those things with the architectural modeling by making that architectural modeling as a base. Okay, then they will only then only they will finalize the structural model after only the structural analysis. By doing the structural analysis, for doing the structural analysis using BIM, we are using softwares like ETABS and STAT. By doing the structural analysis, they can assess the whether they can assess whether the building is safe or or stable. We can analyzing the building after giving all the possible loads coming to that structure, like dead loads, live loads, wind loads, seismic, etc. By confirming the structural stability, we can go for the structural modeling. Like this, Mechanical, electrical, plumbing engineers can make their own models. Analysis in BIM is not only the structural analysis. We can also go for like energy analysis, solar analysis, and shadow analysis also there. By doing the analysis like solar analysis, we can analyze the maximum heat exposure of our building. By using the energy analysis output, we can change the building model to get a better energy efficient building, so that the building energy consumption will be very less. So next is the documentation part. We have to create approval drawings, sanction drawings, shop drawings, as-built drawings, etc. By using the BIM, documentation became very easy, and that means a small correction in the model. BIM makes automatic updation in all the corresponding views. That is what I said earlier. And in BIM, we are making an element which will have all kind of its information, like for example, for a wall, it will include all the informations like what material it is made up of, and what is its dimension, and etc etc, like what kind of okay. In the documentation part, we have to pass all the as-built drawings, shop drawings, etc. Next is the fabrication part. Okay, so many elements in the building can be prefabricated. Only it is needed to assemble those elements in the site, like windows or doors, etc. The assembling of these elements can be better planned using our BIM softwares. So the next one is construction 4D or 5D. We all know what is 2D. Like it is XY drawings, and 3D means XY is a drawings, three coordinates drawings, which you have to digital represent, which you can like you can digital give a digital representation. And the BIM model is not just a 3D model. It will have all the information regarding the building. And also in there is a 4D. What is 4D construction? In 4D, we can do the time management. Every project, there will be a project management area, and the major role will be the time management there, and also budget management, resource management, etc. And they have to manage the time, cost, and resources. That are the keywords: time, cost, and resources. That means they have to complete the project in a short period of the time, in a very efficient manner. And the construction 5D means estimation or budgeting of the building. By making a BIM model, we have to quantify everything. All we have to do is we have to give the correct input automatically. We can extract the estimation part from the input which we are given. And then is the construction logistics, and the operations and maintenance of the structures. And after that, the renovation and the demolition part. In all the stages, we can go for building information modeling softwares. And building information modeling is as I said earlier, it is an intelligent 3D model based process. And we can also develop a virtual model before it is actually actual construction begins, right? And in the BIM, the very important word is the I, because I said earlier that the word I is very important, because the information of all the elements that we are extracting all the informations of the elements at maximum which we can. So that's why I in the word BIM is very important. So BIM is efficient. Like we can go for automatic updations. We can clear the coordination and clashes. There will be very much clash problems between the MEP elements and the structural elements. That clashes can be identified at any stage if you are going through the BIM softwares. And this coordination is very easy when using the BIM process. And in case of for the clashes and the coordinations, we are using the Navisworks tool, Navisworks softwares. And for the time management, we can link schedule date with the model easily. And also the 4D construction. I have already explained what is 4D construction before. And next is the cost estimation. For time management and cost estimation, Time management, we are looking for the software called Primavera, and for the cost estimation, the dedicated quantity estimation and material takeoff tools are there. When we are going for the Revit software, there is the option for quantity takeoff and the material takeoff. We will get all the informations and the quantity and material takeoff of wall, doors, floors, etc. All the elements in the model which we are given. So these data are extracted based on the inputs that we are given, like the properties of the material, etc. And also there is cloud coordinations by using the BIM 360 softwares like that, and the BIM simulation link model with the project and management data. And also we can use the virtual reality construction, which means making use of the power of virtual reality in the construction. Last one is the energy efficiency. Integrated cloud tools to there is integrated cloud tools to evaluate the energy efficiencies of the building. So these are the project stages in BIM. The first one is these are the main stages: design, building analysis, project management, documentation, then construction and operation. And these are the sub stages in these main stages. And these are the main BIM tools that we are using. For the conceptual design, we are going for we can go for Form 360 software. And for when coming to the detailed design, Revit will be the one of the most important softwares in the building information modeling. And the next is building analysis. For building analysis, we can go for Autodesk Insight, then structural exporters to STAD and ETABS. And also for project management, we can go for Microsoft Project, Primavera, or Navisworks also. And when coming to the documentation part, we can use, like for creating shop drawings and as built drawings, detailed drawings also, we can go for Revit software. And also for 3D and drawings, we can 2D drawings, we can go for AutoCAD. And when coming to the construction part, there is Navisworks softwares and BIM 360 Cloud also. And next is operation and maintenance. For that purpose, we are using the Revit software. So next, we are coming to the objectives of our project. We know that the precast concrete construction, which is gaining much popularity now because it has a standardized workflow, right? It works on the principle of modularization. I think you all are familiar with the word modularization. How we can standardize a particular building that actually triggers how efficiently we can complete a building time is the essence, right? We have to save the time. So fabricators now also using BIM widely in their design for the assurance of like fabricated drawings. And also by the usage of BIM, we can collaborate between all the disciplines that is involved in the project. When the fabricators are able to understand the like sequence of the erections of the construction of the building or infrastructures, it will be very easy on the site. Furthermore, prefabricator monitors the element from the design to the erection to ensure the best of the information flow between the departments. Like decisions can be taken on the panel knowing status, and the key of the all precast concrete process is delivering the information needed to the production and ensuring that no further change will be happening to the elements that has been sent to the production in order not to change the mold or rework the same element. So all these decisions prior to the precasting is done in the design stage itself. So, the main objective of our project will be identifying the challenges and the critical success factors for the modularization of the buildings. We will be modularizing the building based on the precast sections. We will be understanding how BIM technology can enable the digital design to fabrication workflow. We will be creating a digital model and associated construction documentation sets for a precast modular building in BIM platform. And we will be creating a study on the ways to on the kind of ways to optimize the construction of precast building using our BIM softwares. So this is the BIM workflow in concept development. The first one is the creation of precast concrete sections in using the BIM modeling tools like Revit, etc. And for next part is documentation of each standardized panel for the casting process. And the third one is the method to visualize and track pre-construction and the tracking of the progress in building stage. That is what 4D BIM. And the last one is crane position analysis to erect the precast units inside. And here is the challenges in construction sectors. We are looking for the best people, and these people work on site quickly as possible. You know, in these days, the people right out of the college might not have all kind of skills required to function in a fully digital world, right? And in built things, the digital world. And in built things in the physical world, not in the digital world, in the physical world, in the same is same in the case of the um construction workers also. And so the another challenge we see and hear about is the digital literacy in some cases. People are using tablets, mobile phones to work with the job sites, but all of the data are translating into the best format as possible for the as possible for work with. We are rely on mainly on the people plan, or we rely on 2D drawings to represent our 3D objects. So, moving towards fully digital literacy is one of the challenges in the construction sector. And finally, the complex projects run typically over budget, and also what like behind schedule, right? Because the collaborations that we have to do are very complex. If one trade is behind the work, then it will affect all the other trades, which is downhill and increases the extra cost. So we are trying to use this building information, data and prefabrication to overcome some of the challenges. So we are seeing with time the digitization of the toolbox, like we are seeing people carrying personal computers on the work site using iPads or phones are pretty much the same way that tapes were being used every day on the construction site, right? So the BIM enables the digitization of the business model. So it is not just the data that we are talking about. So if you are not digital friendly, you will be excluded from the value chain of the sector. So those are the challenges in the construction sector. So next is BIM success factors. We can see many changes that we are incorporating BIM in when we are incorporating BIM in the prefabrication field, such as reduction of the construction costs, reduction of the site labor, increase in the amount of profit that can be generated from a construction project, like then acceleration of a construction project and reduction in the conflicts that arrives out of the building project. So this all digitization of the building business model is just real profit for all the companies. So like well, we have to digitize the workflow directly. Just we have to start it from the architect who designed the building to the civil engineers who need to approve the building according to the standards, and the structural engineers who design the exterior envelope in the load sustaining elements of the structure, the mechanical engineers, then the plumbing engineers who need to create the duct like the work electricity works and the plumbing works which makes the life comfortable inside a building. And finally, the builders and the fabricators work for take of all the data, create something physical out of it. They are actually creating the real thing from the input data. And finally, the building owners are seeing values using the digital data to maintain the future of the assets along the value chain. So here is some difference between the precast buildings and the conventional type of buildings. In the precast buildings, it is designed, manufactured, and tested under supervision of experienced management. But in the case of the conventional building, the concrete cast inside, where the contractors do not take care of much mixed design proportions, right? So the entire concrete blocks are cured uniformly for the required amount of time in the precast building method, and for the conventional method, curing is not done uniformly at site. So there will be issues in due to the imperfect curing. And next is aesthetical pleasing appearance. It can be aesthetical pleasing appearance can be very easily attained in the precast building methods, but it requires special aesthetic design when it is come in the case of conventional buildings. Then the production is not hampered with weather delays in the case of precast building methods, but the production is severely hampered when there is any kind of weather delays or weather cold or other kind of weather conditions. And it is also environment friendly when when we are looking to the precast building method. It is environmental friendly, and then for the conventional buildings it is not environmental friendly. And also the stationary equipment's efficiency designed for repetitive productions, and the cost of formwork per unit to be lower than that of the site cast productions. And for the conventional buildings, the special design and features developed for each project at high cost. And for the precast building methods, the greater it is very flexible, and the design and manufacturing because the design and manufacturing is at the same location. But for the conventional buildings, it is not flexible when compared to the precast building, and the construction is very fast. And also in the but in the conventional building method, the construction is comparatively slower. So next is the most commonly used prefabricated non-modular building elements. We know that they are MEP systems, exterior walls, and building superstructures. When coming to the MEP systems, prefabrication of the complicated MEP systems can help reduce the space required for the ductwork. And in addition, assembly of off-site can positively impact the overall project schedule and keep the ductwork cleaner for sensitive projects like high-tech or biomedical facilities, etc. And in case of exterior walls, the prefabrication of exterior walls can significantly reduce the time required to assemble a building on site. Also, some owners interviews relieve that reducing the exposure to the elements during the construction by assembling the walls in a controlled environment can benefit the all over overall quality. The next one is building superstructure. Constructing all the building above the foundation with prefabricated or modular units is most likely to yield the strongest cost and the schedule benefits, which is probably why those who are using this strategy also report that they use it most extensively. So next is, what is precast concrete? I think you all will be familiar with what is precast concrete, right? Precast concrete is a construction product produced by casting concrete in a reusable mold or form, which is then cured in a controlled environment. Then it can be transported to its site where the construction is carrying on, and lifted and set into the place. So a precast building is constructed by assembling the connecting various prefabricated elements required in the building structures. And these prefabricated elements can be mainly it is precast slab, precast beams, columns, walls, and foundations. Next, it is the what are the difference between the precast concrete and casting situ concrete? Right. So when we are coming to the precast concrete, it is actually a new method, right? And then when we are looking for the casting into concrete, it is a conventional method, and precast concrete method is extensively used all over the world. But it is also used in the India as well as, but not very often. But in precast concrete method, concrete is poured in a reusable mold, cured in a controlled environment, and transported to site and lifted into place. Here, the controlled environment is nothing but a precast plant. And casting site concrete is a conventional method, and the formwork is made at site, and liquid concrete is poured in the formwork and then cured. And precast concrete members are casted and cured at precast plant and then transported to site. Then only the joining will be done at the site. Okay, so In casting of the precast method, in the concrete method, like casting, yes, this is the casting part. Uh, in casting, in case of the precast concrete methods, elements like slabs, beams, columns can be casted in advance. Thus, it saves the time. Whereas, in case of side concrete elements cannot be casted in advance. Next is quality. When looking to the quality, in case of precast concrete, quality can be maintained easily because the precast concrete is made in the factory, and hence the ideal condition and the exact measurements can be maintained through the process. So the precast concrete gives better quality, durability, stability, reliability, etc. And water cement ratio can be properly adopted in the precast concrete. And like in cast in situ, which can lead to better quality control than in cast in situ. Where in the quality of the cast in situ is concerned with the workmanship, where the cement slurry goes wrong through the badly fitted formwork, which can lead to poor quality concrete. The next is labor. In precast concrete, less numbers of labors shall be required, as only joining of the member. There is only like joining of members elements shall be done at the site, and also less skilled labors are required for the work. Hence, the labor cost can be saved. For the casting situ method, more numbers of labor shall be required, like workers like pouring, mixing for pouring, mixing, shuttering, and de-shuttering. Then also for curing, these shall be done at the site. Also for these works, and more skilled labor shall be required. So next is the speed of construction. The precast requires less time for the on-site cast options as compared to the cast in situ method, because the precast members are transported to the site and can be like directly placed on the desired positions, and there is no waiting time to gain the strength. It requires minimal propping and speed. It speeds up the construction time, and it also saves the cost. So the cast inside concrete requires more time because the concrete requires minimum 28 days to achieve its 99% of strength, and its total strength of its out of its total strength. So next is curing condition. In construction industry, curing takes the major time in project completion. In precast concrete method, the curing condition can be controlled in a factory. Hence, high area strength can be achieved by accelerated curing. So there is no need of curing on site. It can be immediately installed. Therefore, it saves the time and cost of the construction also. But in case of the cast in situ, the accelerated curing is really difficult and it's not worth it. We have to wait until the curing period, and this increases the construction period also. And also we know that in the construction industry, the time is directly proportional to the cost. Thus, the cost also gets increases. Next thing is the weather condition. Fabrication of the precast concrete can operate regardless of the weather. It doesn't shrink, distort, or move, and it also doesn't deteriorate. In cast in situ weather, we can delay the casting work if concreting is happening in a cold weather, and it can add like curing time when it is casted in any kind of cold weather conditions. And next is cost. In precast concrete construction, similar types of components are produced fast, resulting in like increasing productivity and economy in the cost too. Right. Thereby we can reduce the time period of the construction, which can be beneficial in the early returns of the investments also. In precast construction, we can say the de-shuttering cost. It requires less number of labors. Hence, you can you can reduce the labor cost too. And like in the precast construction, pre-stressing is also done in some cases, and hence it requires less reinforcement when it is compared to the cast in situ one. So, As per the research article published in the Journal of the Construction Engineering, on an average, the precast concrete slabs are cheaper, like 23.22 percentage cheaper, and the precast columns are 21.40 percentage cheaper than in the cast in place construction, especially for large scale production. And also the shuttering and de-shuttering takes more time and hence increases the cost in case of cast in place construction. Next is standardization and repetition. So in case of the precast method, it repeats similar elements in a wall or a high-rise building. There is greater standardization, and there will be more numbers of there will be more repetition, right? So in the mold for the precast components can be used for large constructions, thereby it reduces the cost of mold per unit also. And whereas in cast in situ concrete, shuttering repetitions are less, and so limited standardization and the repetitions occur. So the precast method is more beneficial when we are thinking about the standardization and repetition also. And next, coming to the material waste, it is very negligible. So negligible when we are looking to the precast concrete, and in the for the cast in situ concrete, the wastage is very more when we are looking to the cast in situ concrete. And in case of the reuse, our precast concrete elements can be reused, extended, and can also be refitted. But it is not possible in the it cannot be reused in the cast in situ concrete. And next is quantity of material. In the precast concrete method, it requires only less amount of cement, less amount of water, less steel, less labor, and also advanced mix designs and better vibrations can be used. But these kind of advanced vibrations and advanced mix designs and better vibrations is very limited. We cannot do these when we are looking into the cast in situ concrete, and in also the cast in situ concrete more quantity of material is also required. But the next one is on-site test. The on-site test is not required for a precast concrete because it is built in a industry. And also the extremely important, and when it is very extremely important when we are looking to the cast in situ concrete method, and we cannot skip. And next is plaster requirement. Due to the plain surface and less quantity of the plaster shall be required in the precast concrete method, and for the cast in situ method, more quantity of plaster shall be required. So next is what are the BIM softwares for the precast construction? Actually, in the area, I have mentioned about some softwares which are using for the precast constructions when we are incorporating this building information modeling in the precast construction. The first one is the Revit, and it is also the one of the most important software in the building information modeling also. It is a building information modeling platform by Autodesk, and it is used to develop architectural, structural, mechanical, electrical, and plumbing models also, BIM models. And it is most widely used for the development of coordinated and clash-free BIM models. Also, the drawings and quantities can be directly retrieved from that model which we are created, and thus in turn we can reduce the cost and time during the installation on site. And this is the interface of the Revit software. And here I have to show you one thing, that there is a new tab called precast, which is added in the Revit 2021 version. Up to 2020 version there is no precast tab, but I think we can use it, like we can add it as like a add-ins or plugins also. By using the precast tab in the 2021, we can go for creating precast models also. For that, we have to take care of selecting the templates, like for drawing walls and floors, we will go for architectural template, right? But when we are going for creating a precast elements, we should go for we should go for the structural analysis template. Then only we can give the reinforcement types, rebars also. because in the architectural tab we cannot in some kind of some in many of the architectural templates we cannot load the rebars. So that's why we are going for we should go for the structured template for creating the precast model, and then we can go for the precast tab here. And after going to the precast tab, there is an option, that first option, split tool. When after clicking on the split option, we will get a that our structural or that our structural model will be changed to precast model. And there is we can there is option for mounting, adding mounting parts, reinforcement, and also drawing options for shop drawings and custom fabric sheets also. So the next software which we are used in the prefabrication, precast construction is Autodesk Navisworks, which is a project review software. Navisworks, it's actually lets AEC, architectural engineering and construction professionals a review integrated 3D models and during pre-construction to better control project outcomes. And it is mainly used for multidiscipline coordinations, like coordination of like architectural, structural, MEP models. And next is clash detection, and the other one is 4D simulation, and next is quantification. So I think, are you familiar with the word 4D simulation? It's actually the virtual construction of a 3D model over time that quickly communicate the building construction sequence and and the extended workflow. And it also enhances the collaboration between the project teams and the clients. And why? How does this BIM 360 accelerate the project delivery? It actually enables any enabling anytime, anywhere access to the project data, and it is delivering information for easy consumption of consumption by anyone on the project, and it also connecting the multidisciplinary project teams across AEC, architectural engineering and construction field, and it's also providing a shared database of project information spanning pre-construction through handover, and also it analyzing data for future planning and executions. So, how can you benefit by deploying BIM 360? It actually delivers the project that are not, that are at or under budget, and it can maximize our resources, and then it can increase our profitability and not sacrifice in the by but not making any kind of sacrifice in our construction quality. This is the world's tallest precast skyscrapers, which is situated in Singapore, and it is named Avenue South Residences. And there is also a lot of precast buildings, and this is the one of this is the tallest precast skyscraper. So the next is like there is a feedback questionnaire. You can go for giving me the feedback, and there is some kind of there is some questions regarding this webinar. And this is our BIM Labs workshop for optimization of precast construction planning using BIM. And this is next on BIM design talk. The topic is steel fabricated building with 4D simulation in BIM. This is our community. You can contact us through these community links. Thank you. Do you have any queries?